All right, welcome back to the LLVM tutorial walkthrough. We're in the middle of chapter 5. We just talked about, in the last episode, we talked about the phi function. Now we're going to implement the code generator for the if expression. Let's do it. Okay, so yeah, okay. So I was beginning to do it in a previous episode. Whoops. I did not mean to jump to the bottom of the file. Let me jump back here. Okay. Okay, let me copy this code line by line and then try to figure out what the author of the tutorial had in mind. Okay, so we're gonna, we're in the if expression AST node. The if expression AST node has 3 child AST nodes. It has the cond. Oh, where's my screen brush? It has the cond node. So if has the cond node, the cond node, and then it has the then node, and then it has the else node. Okay, these are the child nodes of the if expression. This whole thing, this guy is called the if expression. So we're first going to ask the cond node here to generate the code for itself, and then we'll probably ask the next 2 things to do the same. And then this is saying, well, if it didn't work, then everything didn't work. We're just gonna return a null pointer, and then we're gonna actually make a compare instruction, an f compare, which stands for floating point comparison. Let me type this out. I'll do this. Okay, this is a little better. Okay. So cond v. Why v? What does v stand for? We're gonna. This builder is a LLVMIR code builder, and we're gonna use it to build a fcomp1 comparison. I actually still don't know what the 1 stands for. Ifcon. I think this ifcon is just a variable name, a suggested variable name. Yep, so this basically generates the instruction. It generates this instruction is what that line does. This, yeah. And then we're gonna, let's see. What is this get insert block, get parent stuff? I have no idea what that is, but I'm gonna write it and then ask questions later. A basic block is like a code block within which you can write code. So we're gonna create a basic block. Basic block else bb equals basic block create the context else. Okay, we're gonna create a basic block for then and else, but not for if. Why not for if? and then we're gonna create, why didn't we need to create a block for the condition? The condition was convert the condition to a boolean. Oh, this would have already generated it, maybe? That's why? Yeah, this would have already generated into the current insert point. I think that's why. So it has already been added to the tree, in a sense. This call to CodeGen. Okay. So now we're gonna basic. There's gonna be a merge block. And then we're gonna create a conditional branching, which equates to basically this guy, this branch condition. So we're gonna create this branch condition, and I think these basic blocks are going to equate to these blocks. Like this then is a block, this else is a block, and this if cont is a block. So when we're talking about block, we're talking about those things, and this conditional branching is referencing all three of these blocks because it needs to jump to the then and else blocks. Oh, it's not referencing the if cont block, sorry. But the if cont block will be jumped to by this line and this line in the then and else blocks. Okay, so this code creates the basic blocks that are related to the if then else statement and correspond directly to the blocks in the example above. Yeah, exactly. Yeah, I do want to know what this get parent. Oh, I think I know. The get parent is to get the parent function that we are in right now, because we are working with the context of a function. So yeah, the first line gets the current function object that is being built. So when you call cont.CodeGen, it actually generates the line of code. You can think of like this get parent as getting a handle on this bash function, if we happen to be in the bash function or whatever function you're happening to be in. And this CodeGen function, when we generate the code for the conditional, it generates this line. Actually, no, it doesn't generate this line. It generates, if it's a variable reference, it generates just this bit here. If it's a more complicated statement, it will generate more stuff. Like if it's more complicated, it might be like something like that. I don't know. But currently this is just a variable reference here, so it'll generate just this %x, and then but that code has to go into some function, and there's a concept of the current insert point, which is like this entry block. So this CodeGen will already enter the code into this entry block, and the get parent is just getting a reference to this parent function. That's all I wanted to say. Okay. Oh, it needs this function in order to create another basic block, because it needs, is that right? Wait a minute. The then block, we passed the function to the then block, but we didn't pass the function to the else or the if cont block, which is kind of suspicious. Insert the then block at the end of the function. note that it passes the function into the constructor of the then block. This causes the constructor to automatically insert the new block to the end of the specified function. The other two blocks are created but aren't yet inserted into the function. Oh, interesting. Once the blocks are created, we can emit the conditional branch that chooses between them. Right, that was this one. Note that creating new blocks does not implicitly affect the IR builder. So it is still inserting into the block that the condition went into. As in just because we created this then block at the end of the function. You can look at it as you can look at it as we've created a then block, like at the beginning of this code here. Let's start from the beginning. Let's take this slow and explain step by step what's going on. At the beginning of this code, we had the function actually had nothing but this empty entry block. When we did con.CodeGen, I believe it didn't even generate anything until later when we said create this fcomp1. So I don't know if maybe it generated if this CodeGen was not just a simple variable, then it might have generated another expression to get the variable. But I think in this case it didn't do anything with this CodeGen. And then with the create fcomp1, it generates this line here. And then when we say get the parent, it just gets a reference to the function, doesn't do anything. And then when we create this basic block, then it creates this then block and inserts it to the end of the function. But the cursor is still here. I'll write the cursor like this, right? At the beginning, the cursor was here, but now the cursor is here. And we did create this else and if const blocks, but at the moment, we have not inserted them into the function yet. That's what it tells me. And then we're gonna set the insert point to then block. So set the insert point, moves the insert point to this then block so that we can actually generate the code for the then block. And when we just say then.CodeGen, it actually puts code in here, which is when we get this code, I believe, but probably not the branching code yet. So when you say then.CodeGen, it generates the code that's in the then block, and then the insert point now is still in the then block. And then we create this branching statement to get the then block to go to the merge BB block, which is to say it adds this one. The merge BB block is a reference to this if const block, as you can see here. So yeah, so that now we generated this stuff, and then we're gonna ask the builder to get insert block. CodeGen of then can change the current block. Updates then BB for the phi. After the conditional branching is inserted, we move the builder to start inserting into the then block. Strictly speaking, this call moves the insertion point to the end of the specified block. However, since the then block is empty, it also starts out by inserting at the beginning of the block. What? That actually confuses me. I don't understand. I thought we were already in the, I thought the insertion point is still in the then block, and the then block already has this stuff in it. That's what I thought. Because we set the insertion point to the then block, and then we generated code in the then block, so we expect to see code here, but it's saying the then block is empty. Oh, it's saying this line. Oh, I see. The first builder set insert point. That makes sense now. Once insertion point is set, we recursively CodeGen the then expression, and then finish off the then block. We create a unconditional branch to the merge block. One interesting and very important aspect of this LLVM is that it requires all basic blocks to be terminated with a control flow instruction such as return or branch. This means that all control flow, including fall throughs, must be made explicit in the LLVM IR. If you violate this rule, the verifier will emit an error. I like that because it makes me feel more comfortable that when I make mistakes, they'll be caught early. The final line here is quite subtle, but is very important. The basic issue is that when we create the find node in the merge block, we need to set up the block value pairs that indicate how the phi will work. Importantly, the find node expects to have an entry for each predecessor of the block in CFG. Why then are we getting the current block when we just set it to then be 5 lines above? Yeah, why are we getting the current block exactly? That was my question. The problem is that the then expression may actually itself change the block that the builder is emitting into if, for example, it contains a nested if then else expression. So you have a nested if then else expression. The then expression may actually itself change the block that the, oh, I see. I think I understand now. If the then has another nested if statement inside of it, then it's doing weird stuff with set insertion point. So this is saying get the current insertion point wherever that might have been, might be. Is that? Not sure. I'm still confused because if it did move the insertion point inside this CodeGen, when we need to fix that before we create this branching statement. So still a little confused. Because calling CodeGen recursively could arbitrarily change the notion of the current block. We're required to get an up-to-date value for code that will set up the find node. Maybe we do want the branching statement to be there wherever the insertion point was at that point, because we did want it to jump back out. Maybe not so sure. But anyway, so we need to get this updated value. Okay, let's type this code in here. Okay. Next, we need to emit the else block. Okay. Okay, so we're gonna put the block into the end of the basic block list, which is a vector or a collection or some sort. And then now we're gonna set the insert point to the else block and emit code for the else block. This makes sense? And then also we're gonna create a branching statement to jump back to the if continued, which is the merge basic block. And again, we're gonna say the builder get this the same pattern as we did for the then, but it still doesn't totally make sense to me why we're doing this thing. Code generation for the else block is basically identical to CodeGen for the then block. And a significant difference is the first line, which adds the else block to the function, this one. Recall previously that the else block was created but not added to the function. Now that the then and else blocks are emitted, we can finish up with the merge code. Okay. So I see why for this language the five variable is easier to deal with. It's because everything is an expression. It's a pure functional programming language, and the if statement is meant to always return a value. That is why. Okay, we're almost at the end of this section. Hopefully we can even build it and run it. So we set the insertion point at merge bb there, and then we're gonna create this phi node. PN stands for phi node. Okay, so I guess this is the code. Yeah, this is familiar. It is. You first push the block to the end of the function and then set the block as the insertion point. We're gonna create this phi node here, which is basically this line here. This line of C++ generates this line of LLVM, and then add incoming. We have to call add incoming on the phi node to link up this part and this part, and what that does again is it says in our example, if you watch the previous episode, I believe, or maybe where I explain the phi function, this is the phi function. It's saying if you come from this branch, then I want y3 to be y1. If you come from this branch, then I want y3 to be y2. So this one is saying, hey, if you come from the then branch, which the then block, then I want the if temp to be call temp, because the then block set that up. If you come from this else block here, then I want if temp to be call temp 1, which was set up within the else block. So that's what that is saying. So now finally this CodeGen function returns the phi node as the value computed by the if then else expression. In our example above, this return value will feed the code for the top level function, which will create the return instruction. Overall, now we have the ability to execute conditional code in Kaleidoscope. I think that's the end of the first half of chapter 5. It was quite a little bit much to grok with the phi function and everything, but let's see if we can actually build this code. I'm not sure that we can, but fingers crossed. Okay, we still get this error. Okay. Let's see. 350. Line 350. Let's try to fix these errors. It's saying no member called create fcomp1 in builder. Did I mess that up? Let me look at their code. Create fcomp. 1 is in all caps. Oh yeah. Okay. 1 is in all caps. Okay. Okay. Next error is 355. Is saying use of undeclared identifier build. It should have been builder. Okay, that was easy. And then use of undeclared identifier vcon. Yes, I did mean vcon with a capital V. 361. So that needs to be con v with a capital V. And then so it's telling me that conv v was declared over here. Alright, let's compile again. Create BR. Create BR. Create conv BR. It should have been create conv BR or create BR. I think there is a create BR though. No member named conv BR on line 369. Oh, it's R lowercase r. The case matters. One error. It's the same error that I was seeing. Ouch. Okay. Still have to fix this one. but I'm not sure how. So what I'm gonna do, let's save this file. Oh, I already did actually. I'm gonna look at their code because their version of the code does compile and does not have this problem. So perhaps what I do is go to line 333 here and compare it to their version of if expr ast. These are standard unique pointers. Is there a difference between theirs and mine? I do not see a difference. Or maybe there's a difference. I do see this else is green on mine. Not sure why. I'm gonna try copying theirs and nullifying mine. See to check whether there's a mistake in mine. No, that was not it. That was not it. Interesting. So I'm gonna go back to mine. Let me try compiling theirs. Just make sure theirs does compile. And then maybe I'll look for the references to this. Oh, we have these move statements here that I don't have in my version. Maybe that's all I needed. Okay, I'm gonna try again to compile my version. No, it works. Okay, I have to say the error reporting for this problem is not very good. Well, maybe for experts they kind of know that this is the problem. It's also quite confusing to me that even though in my constructor I have these moves, I have to call these moves again when I call the constructor. Like the static initializer, I already have the moves in here, but when I actually construct a new one, I still have to call the move over here. I don't totally understand how the smart pointers work, but I have a working if statement now, or I should. So let's see if it works. So F1, then 5, else 4. Does that work? 1 plus 1. I'm not sure that worked. Let me try their example. The example looks like this. I don't think things are working. It could be that I implemented the parser wrong. That could be the case. So I think I'll need a debugging session to figure that out. But since this video has gone on, I'm gonna stop this episode here, and then hopefully in the next one we can do some debugging and fix the code. See you next time.